Okay, so today's lessons on 1.2, modeling relationships with variables. Our objective is to investigate data to create number patterns. Real life application, well, you can talk about relationships with variables and used for measuring, shopping, certainly all over the place, but it's also used understanding how one object may affect another. It's certainly going to be seen in your everyday life. So definitions, we have 3 for this section, all of which I think you've seen before, so a quick recollection. A variable. A variable is a letter that represents a number. The value of a variable can change. So in this instance, you have 2x plus 6. Our variable is x. And think about that. X is just a placeholder. It's something that you can replace with A, B, C, D. You can use anything. So we'll talk about that in the next slide. Before we do, variable expression, it's a mathematical phrase that uses numbers, variables, and operations with symbols, so addition, subtraction, so on and so forth. Something like 2x plus 6 is a great example of a variable expression. What makes up a variable expression is terms. This is the last definition: a term, a number, variable, or the product or quotient of a number and a variable. So a term is something that is separated by addition or subtraction. So if you had something like 2x plus 6, you can say 2x is a term and 6 is a term. It's things that are separated by addition or subtraction. So let's see an example in play. I'm going to rewrite this because the syntax on the computer doesn't read well. That really just says 7a plus b over 2 minus 5. Could you use a letter other than a or b? Of course. I mean, they're just variables. They're placeholders. It can be anything. You can write 7 cloud plus tree over 2 minus 5, or 7 cloud plus cookie over 2 minus 5. They're just variables, so you can change those to C's and D's. We're going to kind of see that in play the next slide. How many terms does the expression have? Well, let's count how many things are separated by addition and subtraction. We have 1, 2, and 3. So there's 3 terms. Let's look at the next example. How many terms does the expression s minus 2 have? Most of you guys are going to sit there and immediately say, hey, there's 1. But remember, it's what's separated by addition and subtraction. So you're talking about s and what is a negative 2 or 2. That is 2 terms. Let's see a real-life application of this idea of bringing in variables into play. Each CD at a Track 1 Records costs $12. Write an equation that you can use to find the total cost when you know the number of CDs bought. Well, we want to talk about this idea of total cost, so we can say C, I'm going to use C for cost, and it's going to be $12 per CD. Well, how can I represent CD? I'll just use, let's do R. So C equals $12 times R. For each R, we're going to have a cost. So what do the variables represent? And this is going to be a huge thing that we use from now until the end of the year is defining your variables. It's more than just writing variables, but we need to know what they mean. So in this instance, our C represents cost or total cost, and that R represents the number of CDs you buy. Make sure you define your variables. Just like you're writing a paper, you want to have an introductory paragraph when you first open up what you're writing about. It's the same concept. You need to know what you're talking about. C equals 12 times R doesn't mean anything unless C has a value. C is cost. R means nothing unless it has a value. R is CDs. So a worker says, let's look at the last example. A worker says 5 CDs cost $120. What is the mistake he made? So they're telling us there's a mistake. Well, let's go find it. This idea of 5 CDs. Well, we use that to represent R. R is 5. Let's plug it into the equation, this one right here. You have C is equal to 12 times 5. In this instance, you'll get C is equal to $60. So the worker's charging him him or her $125. $125 for those 5 CDs, but really they should only be charging him $60. So that's a huge problem, a definite mistake, almost charging him double for those 5 CDs. The last example, we kind of saw how to just take like a phrase and to turn it into an equation. Now let's look at the tabular form, taking a table and making an equation. So here's a table. It talks about number of sales, 1, 2, 3, 4. Total earnings, $2, $4, $6, $8. Use an equation to model relationship in each table. So total earnings, I'm going to use T, and sales, I'm going to use N. So I define my variables up there at the table. Total earnings T, number of sales N. So we want to figure out, well, for how many sales do we have this total earnings? We look for one sale, we bring home $2. We go another sale, we bring home $2. Another sale, we bring home $2. In other words, every sale brings us home $2. So T equals $2 times N. And this is perfect. We can even use this to check our work. Let's say we brought home, or we got 4 sales. Plug it in. T is equal to $2 times 4. T is equal to $8. Our total earnings, perfect, $8. So that's like an introductory lesson into what a variable is with variable expression and terms. We're going to be using this for the rest of the year, so get comfortable with the idea of variable. That's it for 1.2.